Hi, I'm Chris Huntley, your instructor for this introductory course in Python programming. Starting from the very beginning, we will learn just enough Python to prepare you for more in-depth courses in business analytics. First, however, we need to cover a few details to get you ready. My programming journey started in the late 1970s. The language was BASIC, which we used over a teletype machine connected to a mainframe at a local university. For several years, that was all I knew. While the teletype was eventually replaced by an early personal computer in my physics teacher's classroom, the language was always BASIC. Then in college, I learned my second language, Pascal, which introduced me to structured programming and more advanced ways of handling data. By the mid-90s, I had mastered a dozen languages, none of which were Python, which I didn't learn until after I got to Fairfield in 1997. I think I've probably learned another dozen languages or so in the years since. Whenever possible, we're going to concentrate on general programming principles before getting into the details of Python. So, with that in mind, let's review a few big picture concepts that will drive the rest of the course. First, computers are surprisingly simple machines. They can do amazing calculations at lightning speeds, things that are impossible for us humans. However, they can't yet do a lot of things that humans can do in the first few weeks of life. Instead, we have to teach computers how to do things by either giving explicit instructions or feeding them lots and lots and lots of examples. And then, even with our help, they can still make mistakes that you and I would never make. So if you want to improve your odds of getting computers to do exactly what you want them to do, it's a good idea to learn to program. With well-written code, we can tell the computer both what we want it to do and how we want it to do it. As we get better at this, we also get better at programming, even as the technology evolves over time. Many of the languages I use today, I learned after I got my PhD. The learning process never ends. This leads to why you should learn Python as your first programming language. First, Python has demonstrated to be comparatively easy to learn, with a minimum of clutter and ceremony to memorize. Python is also a very logical language, where most things do exactly what they look like they do, without a lot of magic that gets in the way of understanding and fluency. It is about as frictionless a language as it can be, allowing skilled programmers to write code about as fast as they can think. Finally, Python has amazing industry support, with more and more Python software available for us to use for free. This is especially true in analytics, where a couple decades of heavy adoption by mathematicians, scientists, and others who work with data for a living has produced an almost endless array of remarkable analytics software. Perhaps it will help to get a little context by going all the way back to the very beginning. The earliest digital computers were really more like glorified switchboards with lights that lit up when you turned a few switches. We represent these switches with zeros and ones, and even today that's how computers see the world. Eventually, as IBM and others introduced business applications for computers, higher level languages evolved that made it easier for humans. We still use some of these early programming languages with names like COBOL and Fortran, even as programmers who know them well are a dying breed. Until the late 1970s, computer programmers usually worked in labs with white coats and plate glass. They were computer scientists and engineers with advanced degrees. Then, with the advent of the personal computer in the 1980s, it became commonplace for everyday business and home users to write their own programs. Python, which started as Guido von Rossum's hobby project in the late 1980s, was the product of this tectonic shift from science to software for the masses. Another, by the way, was the World Wide Web, which also started as a toy project in a science lab in the late 80s. That leads us to today, where accountants, market researchers, and others use Python for things that the white-coated scientists could never have imagined. I'm sure they would be delighted. All of this is a long way of saying that there is no reason not to learn Python. It can only help you get things done, especially if you want to work in analytics. Excel is fine, but Python is just so much better. In order for this to work, we're going to have to work together for the next several weeks. That means setting expectations, both about your work and what the course should provide in return. It's a professional relationship, as it should be. More about that later. This is a course intended for business analytics students, so please don't come in thinking we're going to turn you into systems engineers. Those guys are the ones on the right. Instead, we assume you want to be the one in the middle, providing analyses to your business clients on the left. When thinking about what you will achieve in this course, we make a distinction between theory and practice. Theory refers to things you should know and understand. These include concepts that apply in just about any programming language, and of course the specifics of how Python does things, especially as it's used in data science. Practice refers to things you should be able to do in Python. Ultimately, the goal is to write scripts of moderate scope and complexity using the same software libraries and tools that you'll find at Google, Netflix, or any other leading data science shop. For many of you, this is your first class in grad school. Welcome. We're glad to have you. One thing you're going to have to get used to is the faster pace, with a typical grad class covering about twice as much and going twice as deep as your previous classes. In order to succeed, you're going to need to jump in feet first and then learn to swim on your own. This is not the place to sit back and let things wash over you. Seek out the deep end of the pool and try your best to keep your head above water. In this class, that means learning as much as you can with fingers on the keyboard and your mind fully engaged. Anything less just will not work. You really don't want to fall behind, because each thing we do brings you out further and further, and nobody's going to swim back to pull you along. Everybody else is trying to keep their heads above water too. We all know that cheating, free riding, and other dishonest behavior are rampant on college campuses today. Please resist the urge to follow along with the slacker crowd. Grad school is different. It's guided by a social contract that values, number one, integrity over grades. Unless you're flunking out, nobody's going to care about your grad school grades. Instead, they care about whether you can do the things you claim to have mastered. Number two, courage over ego. Prepare to make lots of mistakes. You're here to learn to do hard things, right? So, it's better to be coachable than to prove you're always right. Let go of the ego and let the learning process happen. Number three, community over competition. Grad school is as much about building your professional network as it is building skills. Your classmates are that network. While it may seem like you are competing with them for attention, jobs, and other rewards, instead think of them as co-conspirators who will help you get those things, perhaps years later, long after this class is over. Of course, that can't happen if you're a bad citizen. If you can't abide by these values, then please take another course. It seems weird to be talking about values in a programming class, but here we are. You see, analytics is a profession. We get paid to do things right, and to do that we need knowledge, skills, and a code of conduct that guide how we do things, even when we get the wrong answers. So, what are these things you will do, and how will we know if you're doing them right? In this class, you will complete different kinds of assignments. 1. Readings that cover the basic theory with examples. 2. Data camp tutorials to provide opportunities to learn on your own. 3. Lessons that build on the readings with even more explanations and hands-on exercises. 4. Quizzes that test your proficiency with the essential concepts. 5. The final project, which integrates it all into an authentic learning experience. While you're responsible for completing every assignment, the readings, tutorials, and lessons are considered formative, graded for effort rather than outcomes. It is enough to simply complete them the best you can. Quizzes and the final project, on the other hand, will each receive a letter grade that factors directly in your course average. All assignments with a numerical score will be curved on a GPA scale, with the average being 3.5, which is an A minus. Above 3.67 is an A, between 3 and 3.33 is a B plus, etc. This is somewhat a forgiving formula that reflects our values. If you need grades to motivate you, then think again about why you're in grad school.